This is the third in our series of 4 lunchtime talks to do with the Acute Care Wing. This one is on future proofing, and today our guests are Richard Noel, the project manager for the site, and Jayne Craig, the mechanical and electrical manager for the site. We're going to be talking today on future proofing of the building and really the sophistication of the building design. So, put on my glasses. So we've been boasting that the new wing is a state-of-the-art facility. How true is this, guys?
Thanks, Kathy. I, I think from the outset, from the bid phase, BHB took into consideration what the needs of the island were and have built into the specifications the highest levels of quality and looked at long-term durability. And so as part of our design and build works, I mean, we've had to obviously meet the output specifications. And really, I mean, we have a lot of latest technology. A lot of the specifications that we originally had were designed to bring the latest technology to Bermuda from an architectural point of view. The infection control policies that are now in place and getting more onerous around the world have really stepped up to the mark in this new facility. I guess if anybody's been in the old facility, they'll know some of the problems that are in there. So internally, I mean, you notice a lot of plasterboard and or standard-looking walls, but what we've built is a new type of plasterboard that is totally mold resistant. I mean, you basically leave it outside. And it'll very well. It won't grow mold on it unless you put food on it because it's made out of fiberglass. And a lot of the products, we haven't done normal ceramic tiling. We've put wall finishes up that are basically sheet materials that are easy to clean. And floor finish as well. We've looked at longevity and made sure that you've got suitable floor finishes for the purpose of the building. So I mean, that's the sort of thing you see. Plus the building's designed as a post-disaster building, so it's designed to a 1 in 500 year storm event, which is pretty high standards. It's designed for basically it's sort of hurricane criteria, so that there's a lot of analysis done and on what sort of likelihood you might have of a 1 in 500 year storm. So I mean, it's basically the highest category of hurricanes that you can design for. So the building's designed for that, for impact resistance, so it's not damaged during the hurricane. It's designed for earthquakes as well. So in the event of a major hurricane or earthquake on the island, it's the place to go, place to hang out. But then again, moving forward, there's all the internal services which are also top line services in line with any other facility that you get in the States, Canada, or the UK.
It's probably worth saying that in some of the specifications that BHB and their team put together originally, it was actually written into the specifications that we had to select the very latest technology in terms of the IT services, some of the active network equipment, some of the medical equipment, and a lot of the procurement of those items was held off till quite late in the project, so they could make sure that they had the very latest MRI machines and IT equipment.
So you say that was part of the specifications that they had. So did they specify that they were going to do that, or did you have to choose? You had to do the research for that. How did that work?
Well, It was a bit of both, depending on what systems you're talking about. For the ICT systems, most of the active equipment was within our scope of works. So it was written into the spec that in consultation with BHB, we'd need to make sure we were selecting the very latest Cisco technology to make sure the network was very current at the time, because obviously this equipment gets replaced quite quickly. But the medical equipment procurement was done slightly differently, so BHB actually did the selections, but the timing of it again was left as late as possible, so that we could still construct the building and finish it on time, but to make sure that the very latest technology was going into the hospital.
Thanks very much for that. Sounds really interesting. So, the new wing is state of the art in terms of buildings for Bermuda. You're making that very clear. But how does it measure up to state of the art in terms of buildings elsewhere in the world, in particular in North America and the UK?
Yeah, I think technology is always developing. I mean, this new hospital would be comparable with anything in the States or Canada or the UK that's being built at the present time. In 5 years' time, there'll probably be some more new technology that's come through, but it's got the latest current technology in the building. So you wouldn't find. You may have other clinical modalities in other hospitals that we don't have here, but anything that we have provided in the sections of the hospital that we've provided in the new acute care wing is certainly the latest, as good as anywhere else that you'd find in the world at the moment.
So, Jane, can you tell us a bit about what it was like to choose the sort of boiler room equipment? I believe you were involved in that, given our remoteness here.
Well, I guess the first thing to say is, in terms of some of the equipment selections, the performance requirements and overall requirements for capacities for some of those items of plant and equipment were originally written into the BHB specifications. So we had an obligation to comply with those. Once our team got into the detailed design, so the full details of the sizing, then you have situations like the steam boilers, where we have two steam boilers, either of which is capable of taking the full load for the new facility and the full load for the existing facility. So once all of the design and sizing calculations are done, then we go out to the market, to steam boiler specialists, and try and find one that's most suitable. Maybe taking into consideration things like the lifespans of the equipment, the sort of service you get, a remote location, and what kind of service levels you need after the building's complete, footprints and all sorts of things to try and make the best selection to get it to fit within the new building.
Are you able to tell us a bit? I think that the audience would be interested to know sort of the capacities of that type of equipment, just in general terms.
Sure. I mean, I can go over. I brought a cheat sheet with a couple of numbers just in case. So, in terms of the major equipment, from a mechanical perspective in the building, we have 21 air handling units that take care of all the fresh air requirements and the cooling in the building. Altogether, if you take all of those units together, we supply about 160,000 cubic feet a minute into the building. As part of the ventilation design, in terms of future proofing, there's overall about 28% margin. So those units together are capable of providing something like 205,000 CFM. So there's future capacity there if any of the departments change from more administrative accommodation to a high level clinical need. We have 3 chillers in the building that take care of the cooling. They're each about 1,000 tons. So I mean that's a pretty vast quantity.
But these were
We have
the chillers. The chillers were also
yeah. So for most of the mechanical plants, the way it was sized and the way it was required by BHP was to serve the new facility, and then have a 20% allowance on top of the new facility requirement for future changes within the building, and then for the chilled water, the steam, the low temperature hot water heating systems, all of those were then also sized with the existing facility load. So they're basically there to serve the new facility an extra 20% and the existing building. So yeah, from a chilled water capacity, that comes to just under the 3,000 tons that we have in the new facility, and then we also have in the basement plant room space for a similar fourth chiller. So if there's ever any major redevelopment, further redevelopment on the site, there's you can add another 30% plus to your chilled water load. So yeah, we've got some pretty big equipment in the main basement plant room. So on the chilled water system, the 3 chillers altogether will produce about 3,000 tons. The new facility is using about 970 tons of that, and there's 890 goes to the existing facility, and then basically the remainder is there for refurbishment in the existing facility and any other future expansion. So it's kind of a third each way, plus space for an extra chiller on top. So there's a good amount of capacity there.
We heard from Travis Berlin in our last talk last week, Thursday, who talked about the solar panels and the heating of the solar panels, heating the water, and how that's topped up by the boilers. Do you want to talk about that? Or is it not interesting?
It's kind of interesting. I mean, the water systems in general in the hospital are quite interesting. On the cold water side, we have to, and you can't see any of this from outside, obviously, but beneath the basement plant room, if any of you guys went past early in the project, we started out by digging this huge hole in the ground. So we've got 300,000 gallon domestic water tanks beneath the basement. So we go down sort of 35, 40 feet below ground level. And we actually have 4 different ways of getting water into those tanks initially. So we have a supply that comes off the government water main. We've got a supply that comes off the Watlington water main. Primarily the tanks are going to be filled by collection from the roof. So it's the same as your house, just on a much bigger scale. And then we have finally, although for the size of the tanks not going to be all that useful, we have a tanker connection as well. So you could literally queue trucks up and keep filling the tanks up. So that's the domestic cold water system. The hot water system, as Travis mentioned, so we have these solar thermal collectors up on the roof, which they're basically big black panels with pipework run through them and lots of fins to try and collect the heat from the sun. So that preheats the water, and then we use that preheat with the calorifiers to get the water up to hot water temperature. And all that is really part of the sort of sustainability of the whole building. I know Travis will have talked about the LEED certification that we're going for the new facility. So there's lots of small items like that in relation to energy efficiency in terms of the equipment to try and get that certification.
So was working on that LEED certification like that new for you? Because you do this all the time.
No, you carry on.
Thanks. It is. We have a similar system in the UK, which is called Brian, and a lot of the credits are very very similar. So there's things like some site management elements as well as overall the equipment that goes into the building. The interesting thing on this one, or the biggest one of the bigger challenges in terms of the credits was we had to achieve a 26% energy cost reduction against as a published baseline in the States, and that was quite a big challenge to get to that. So they have basically a model hospital building, and they tell you how much energy you should use, and we had to take that as a baseline and reduce it by 26% to get down to the lead requirements, and that gave us. There's different levels, so you score points in the So
built into to achieve the reputation, you needed a 10% reduction in energy saving, but as part of the output specifications that we were given to start with, the BHB asked for a 26% energy reduction, which is pretty high. It gets you a lot more points, but
so
it's.
for the 10%, which is a mandatory, to score 2 points,
Yep.
and all those the solar thermal collectors and also reducing the rainwater collection out of it. That's a little unique, just in terms of the quantity of rainwater we're collecting. It's going to take care of the redundancies and that. So we got extra points for that.
So, Richard, if you can tell us a bit about what was done in terms of the actual construction that allows for expansion. I know that Jayne's touched on it a bit in that there's some extra room for another chiller, a fourth chiller if need be. But structurally, what did you do?
Yeah, I mean, Jayne's run through all the most of the expansion requirements in the M&E services. Structurally, we had to allow for expanding the building in 3 directions. I guess it could have been 4, but the site was a bit restricted, so we haven't got any allowance to expand towards Point Finger Road because you'd obviously lose the access roads. But as part of the structural design, when all the foundations were designed for the basement tanks, or sorry, not basement tanks, but the main basement, the foundations were extended. The foundations were designed to pick up the load, the structural load from a new building of the same height. So the foundations were designed oversized, and then we've built our retaining walls for the basement, and on the extended foundations we've put in basically short stub columns so that you don't have to expand the bases if you ever need to expand the building. So you just excavate down to the columns that we've put in and then just start building off them. So you wouldn't have any impact on the existing building. So we've done that on the south side, where the new ambulance canopy is, down the east side, so you could expand towards botanical gardens, and on the north elevation where the new main entrance is, which, as it looks sort of possibly likely in the future, the CCU will be knocked down. I mean, they're probably the foundations that are most likely to be used. So if CCU was ever knocked down, you could then build a similar building or another building going forward without impacting the existing or our new facility. I guess structurally that's sort of the main expansion. there is also the possibility of doing some expansion on the roof. The main roof has been designed, or the columns that go up through the building to the roof and hold up the roof are designed to take well, initially they were sort of designed to take some additional plant up there, but you know they could be used for expanding the building up another story or so. I know there were talks about putting restaurants up there and things in the early stages, but it's a tremendous view from up there. Yeah, so I mean, there's horizontal expansion of the building and vertical if it needs to be expanded.
Great, fantastic. Thanks. I didn't realize that. And for members of the audience who might not know what CCU is, it's our continuing care unit where we have people, it used to be called the extended care unit. And there is talk that that building is aging and might need to come down. So Mr. Noel's saying that if it does have to come down, the structural reinforcement is already there, which is fantastic because I do know that that was part of the problem why they were looking to go to the botanical gardens originally to build. They didn't want to build so close to the existing hospital and said it would interfere with the running, with the service of the hospital.
I mean, sorry, I'm just as an example, I mean, where we've had to build the Link building, and the new pharmacy that sort of got added in later. It's very difficult to build those buildings when the existing building hasn't been designed to have a new building built next to it. You know, you have to be very careful with the existing foundations, not to cause any subsidence of the existing buildings. So, you know, that's been taken into account with the new facility, so it will be much easier. And, you know, you wouldn't have the restrictions that we had, or put the temporary works in place that we had to make sure that the new facility doesn't move or collapse, but it's never likely to do that.
Well, that's fantastic. Also, inside the building, you've included extra ductwork and piping for things that might have to happen in the future. Is that correct?
I can say something.
No, you can if you like.
Might not be right.
Pipe and duct. So, I mean, obviously we talked about some of the central plant and the extra capacity that we've got in there, but also in terms of a lot of the distribution that goes through the building. So the ductwork, for example, has all been sized to suit the airflows that we need in the areas, but then we've also added 20%, so all the ductwork is slightly bigger. So if, for example, an admin space changes to a more clinical space, you tend to have to put more air into those spaces and extract more air out. So all the ductwork's got some future proofing in it. We did also undertake an exercise of adding some additional drainage pipework that's capped off at sort of high level and level 1 to serve level 2, which could be used for future clinical space to if they ever chose to develop some of the office space they've got in level 2. So there's all extra drainage points, so you just need to pick it up locally rather than go back downstairs and start tearing ceilings down and stuff like that. And we've also put in some spare conduits for electrical services and bits of connections between the new facility and the existing facility. And what else have we got? Obviously got quite a lot of pipework that routes through the basement for those future services that we talked about earlier. So not just to serve the existing building with, say, the chilled water, but we've also got a connection there for a future facility. So yeah, it was tricky finding space to get all of it in at points.
Did you have anything you wanted to add to that, Richard? So if we needed more clinical equipment, because as time progresses, like you said, technology is always advancing and we might need to get some particular equipment in there. We've got the ductwork. You've already made provisions for the electrical and so forth to take place, yes? Okay. So, I've said that you've said redundancies have been built in. Give us an idea of the scale. I think you've really done that. Did you have anything to add to that? I think yeah, but about redundancies and so forth. Like I'm always telling people we've got a backup generator, and then we've got a backup generator for the backup generator. Is that true?
It's not entirely true. So on the electrical side, coming into the building for the normal power, we have two HV switches and two transformers, and each of those are 2.5, say megawatts. That's not quite technically accurate, but 2.5 megawatts, and then you can force cool them to get some more capacity, so you can get up to 3.3 megawatts out of each of those. So they're roughly sized to take most of the building load just from one transformer in the event that one fails. Now you would lose some non-essential services in that event. The generators themselves, in terms of capacity, are slightly smaller than that. So I think they're 2.25 to maybe 2 megawatts. So what happens electrically if things start to go wrong? If you lose one transformer, you'll still take most of the load of the new facility on the remaining transformer. If and both of those are fed with two separate feeds from Belco. So chances are you're always going to keep one transformer even if something goes down. If for whatever reason Belco had a big failure at their side and you lose both transformers, then you have the two generators. Now, what happens in that event is you kind of shed some of the load on the building, so you take out things that aren't really needed. So you have lots of different types of power throughout the new facility, on different branches, coming from various panels, and some of those are really important to stay on. So some of those will be backed up by the clinical UPS. So even when you lose the power, it might take 8 seconds for the generators to come online. For the really essential stuff, that's backed up on the clinical UPS, so you don't see any power loss at all. And then for some of the important stuff that's slightly less critical, they wait for the generators to come on. But we don't always bring all of the normal power back on. So if you've got a TV in a waiting area, say that's off general power, you don't really need it if you're having power difficulties. So you lose some of the non-important stuff. And then in the event that you had a problem with both of your transformers and a problem with one of the generators, again you take out or you bring back on a few less of the electrical services, but you're always trying to maintain the important sort of life safety systems and some of the important clinical functions, even when you've lost 3 major bits of equipment out of 4. So.
Thanks very much. And I think I was reading in this exhibit somewhere that the generators are considered extremely important to the point where the fuel storage tanks have sensors so that they always keep them supplied. So
there's a whole control system that goes with the fuel system. So the fuel system serves the generators, also serves the heating boilers and the steam boilers. There's a lot of reasons you have the control system for the fuel side. From some of it's environmental. If you've got a leak anywhere, you want to know about it. You don't want to start spilling fuel anywhere. If you've got a leak in the building, obviously it's problematic. But yeah, so there's some quite complicated controls to keep an eye on. I mean, and this doesn't just apply to the fuel system. Really, all the systems in the building we have a full building automation system that really monitors all the services from fuel oil to generators to air handling units, boilers, all the main equipment and some of the small equipment, so that we'll get any alarms if something starts to go wrong. If there's a failure on a pump, say, get an alarm up so a guy can go and try and fix it up. On some of the more critical systems, you'll have what we would call an M+1 arrangement, where you'll have two identical pumps. So if one of them goes down, you can still keep the whole system running, and you can replace that pump. Obviously, some of the consideration there on the systems is to do with how difficult it is to get materials here if they're not readily available on island. So when the guys are doing the design, they were taking a view on how essential the systems are, what sort of lead times might be involved with replacement components and equipment. So there's a whole very complicated automation alarm system that keeps an eye on everything and gives you forewarning basically if there's anything that's about to go wrong.
Any questions? Miss Laura?
Well, there's the yes. I mean, there's post-disaster recovery points outside the building. So I mean, you can.
Yeah, there's and when we say post disaster, for cruise ship, obviously it's a big new building with 19 patient bedrooms. Don't necessarily have the capacity or need to build a hospital capacity to take in 300 patients into the units. So we've got two main areas dedicated for post disaster. One's the main entrance, which is a brand new automatic open space. So that would be used first because it's
Enclosed,
usually
yeah.
there's a second area where the ambulance campaign car park is. So and that's quite a big area. So if there ever was an emergency, you'd probably use both those spaces. So we've got power and water data provisions out to those spaces. So it's temporary hookup and triage or kind of when we can take some of the hurricanes, and their seismic side of things. All of the systems inside the building have been designed so that if there was a major incident, we've still all of the mechanical and electrical systems will still conservation functionality from a building point of view. The windows are hurricane rated. There's special impact resistance tests that they had to do with small and large missiles, was it?
Yeah, I mean that's all designed to basically meet the South Florida building code requirements, which are really the most onerous for hurricanes. And I think it's sort of going back to the earthquake issue. I mean, there's all the seismic bracketry that we've put in on, which is really unusual for. You might have the odd tremor now and again, but if you have a major earthquake, what tends to happen is everything shakes loose and falls out the ceiling. So we've had to put special seismic brackets in on all the services to restrain them if there's a large earthquake. So there's a lot of things that have gone into the building that you wouldn't have on a normal building, and that's all really to do with the sort of post-disaster stuff, where it helps with it.
Because of the location of it's environmentally important that every hospital catastrophic shift in island. So all of the resiliencies that we talked about into the systems and into the side parameters all that just to try and make sure that any kind of incidents still be able to use it. It's one of the fundamental concepts.
Well, I think the interesting thing is that where we have joined on with the Link building onto the CCU corridor, and we've also sort of built onto the main existing facility with the sort of link bridge at third and fourth floor levels. But in the event of a catastrophic earthquake, the old buildings are likely to fall down. I mean, we're not actually connected. We're you wouldn't know that we weren't connected, but we've got an isolation joint that allows for, I think, up to 6 inches of movement. But you know, in the worst case scenario, the other two buildings could collapse, or the CCU corridor and the existing facility could collapse, and you'd be left with the new acute care wing. I mean, so don't worry too much about it.
I'm sure that's good to know. We all know we'll all be safe if an earthquake's going to hit. We'll know exactly where to go. So thanks very much, everyone, for coming out today.